This video is going to go through the notes for 1-6 linear systems of equations. We're actually going to look at solving algebraically rather than graphically like you did in the Explore and Reason for 1-6. So we have our essential question: how can you find and represent solutions of systems of linear equations and inequalities? We are actually going to focus on the equations today. We're not going to do anything with the inequalities. So we have a few definitions here. We have system of linear equations. That's going to be your set of two or more equations that are going to be using the same variables. So if you have two equations, both sets of equations have the same variable. It's not like you have two variables in one and then two completely different letters in the other one. They're all going to have the same letters in them. Your solution is going to be the set of all coordinates that would simultaneously make the equation in your system true. That means when you plug your solution back into the original equations, the left and the right sides are equal. So the first method we're going to look at is substitution. Substitution is very useful whenever one of your variables has a coefficient of 1. And you can see here the y value the y in the very first equation. And I'm actually going to number these using Roman numerals. So whenever I reference them, I'm going to reference equation 1, equation 2. So the y in the top equation has a coefficient of 1. That means that this is a good candidate for substitution. You could also use the x in the bottom equation, but you would have to divide by the negative to get the x by itself. So the first step is find your variable that has that coefficient of 1 and isolate it. So you want to move everything away from it. So in equation number 1, I'm going to be getting the y by itself, which means I'm going to be adding the 8x to both sides. So I have y equals -4 plus 8x. This is not graphing, so it is not essential that you put the x term in front of the number term, because sometimes whenever you're doing substitution, you might actually have to solve for the x and not for the y. So you don't really need to worry about where your variables go as long as what you're trying to get by itself, like this y here, is on its own. So now once you do that, you want to look at your second equation. And we already said that y is equal to this -4 plus 8x. So the y in the second equation, instead of writing that letter y, I am going to write -4 plus 8x in parentheses. So my second equation is going to become -x minus 2 times -4 plus 8x, and then equals 8. You see how I wrote everything else in the question, but instead of writing that y, I replaced it with the expression that y is equal to. Now I have one equation that just has x in it, so I'm going to go through and solve. So I have -x, I have to distribute this -2, so that's plus 8 minus 16x is equal to 8. Combine your two x terms, you get -17x, then I have the plus 8 equals 8. Well, when I subtract 8 from both sides here, I'm actually going to end up with 0. So I get -17x. -17x is equal to 0, which means when I divide, x is equal to 0. 0 is a perfectly acceptable number. That just means that the number value is 0. We can actually plot an x of 0 on a coordinate axis. So just don't be thrown off if you do get an answer that is something like that. This is not the same as no solution. 0 is an actual number. So now, once we have this x, I can take this x value and plug it back in to that original equation where I solved for the other letter. So instead of writing the x again, I'm going to replace it with the number 0. So y is equal to -4 plus 8 times 0. Well, 8 times 0 is 0. That means y is equal to -4. So the only thing left to do is to write our solution as an ordered pair. Ordered pairs are where you list the x value first and then the y. So my ordered pair would be 0 and -4. So if you were to graph both of these equations, they would cross at the point 0, -4. And that's what solving algebraically does for us. So now we're going to look at a different method. This method I can see a lot of you guys using more often than substitution. This one usually does not lead to any chance of fraction when you're going through and solving, unless your final answer is a fraction. And for most of what we're going to be doing in class, I'm going to give you problems that do not have fractions as their answers. That way you guys can be sure that you're doing your work correctly. So elimination is where you would add your two equations together to eliminate a variable. Now sometimes you're going to be able to eliminate the variable right away. Sometimes you'll have to multiply by a negative to eliminate a variable, and sometimes you'll actually have to multiply by an actual number, either in one or both equations, to be able to eliminate. So again, I'm going to go through and number my equations, 1 and 2. So if we look at our variables, I have x's and I have y's. And if you notice, the x variables are opposites. So the x coefficients are opposite. Opposite would be the positive and negative of the same number, like 5 and -5 that we have here. When your x coefficients or y coefficients are opposite, you can start off by adding your two equations together. The goal here is to have one of your variables add out to 0. And that's what happens with the first variable. -5x plus 5x is 0x, which is gone. I still have to go through, though, and add the y's and then add the numbers. Please make sure you are only adding things that are alike. So 6y minus 5y is going to give me a 1y. Now, you may get a coefficient here that's not 1. If you would just have to divide the next step to solve. -8 plus 5 is -3. And there's my y value. My y value is -3. Once you have the y, you do need to have the x in order to finish out our ordered pair. So then we take our solution and plug into one of the original equations. So it doesn't matter if you use equation 1 or equation 2. I'm actually going to plug into equation number 2. But you would get the same answer if you plugged into equation 1. So we have 5x minus 5 times -3 is equal to 5. -5 times -3 is a positive 15. So I get a positive 15 is equal to 5. Subtract the 15 from both sides. You get 5x is -10. Divide by 5. X is equal to -2. So my solution, my ordered pair, is -2, -3. Notice even though I found the y first, I list the x first because ordered pairs are always listed x, y. If you wanted to check your answer, you could plug in the -2 for the x and the -3 for the y in both of the equations and make sure that the top and bottom, the left and the right would add out to be equal. So the left and the right would give you the same value. Okay, so this is example 3. Again, we're going to solve using elimination. And remember, the first thing is we want to look and see if anything is opposite. And right now, nothing is opposite. Because opposite, you have to have one positive, one negative. However, I see something that's the same. And again, there's my 1, there's my 2. My 1 does not look quite like I would like it to look, so I'm going to rewrite that one. So in equation number 1 and 2, the x's are the same. I need to make them opposite. That's the only way that we could do this because we're always adding the equations together. And if I were to add them right now, nothing would add out. I'd have 12x minus 11y. I want to get rid of one of those. So I actually have to multiply one of the entire equations by a negative. I'm going to go ahead and multiply the first equation and keep the bottom one the same. So when I say multiply, that's actually what you're doing. You're going to be multiplying every single term in that top equation by negative 1. So we're going to get negative 6x plus 8y equals a positive 22. Notice everything changed sign. The second equation is going to stay 6x minus 3y is equal to 18, and now I'm able to add my two equations together. The x's add out. 8y plus a negative 3y is 5y, and 22 plus 18 is 40. So to finish this out, because it didn't give me a coefficient of 1 like it did in the last problem, I would divide by 5, and we get y is 8. Now, just like we did in the previous problem, I'm going to take that 8 and plug it back into either of the original equations for y in order to solve for my x. So I'm actually going to plug into equation number 2 again. So I have 6x minus 3 times 8 is equal to 18. I multiply the negative 3 and the 8. So I get 6x minus 24 is equal to 18. Add the 24. 6x is 42. And then when I divide by 6, I get x is 7. So my solution is 7, 8. Again, I list the x first and then the y. So this was elimination when you had to multiply by a negative 1. Sometimes you don't even have that. Sometimes you have a situation where nothing is the same, nothing is opposite. So then you'll have to think about what variable you want to eliminate and what you want to multiply by. You can make the choice if you want to eliminate x or eliminate y. We've done a lot of eliminating x, so I'm going to go through and eliminate y here. You do want to make sure that one of your variables is a negative. So with the y, it's already a negative 7, so I don't have to multiply by a negative to make it a negative. You either want one negative, one positive. You don't want both of them negative, don't want both of them positive. So to turn my y's into opposites, in equation number 2, the y term is already a 14. If I could turn the top equation's y into a negative 14, then they would add to 0. And I can do that. I can multiply negative 7 by 2, and that would turn that into a negative 8 or a negative 14. So I am going to keep the bottom equation the same, and I'm going to multiply the top one by a positive 2. So remember, you have to multiply everything in the equation. The x is going to become a 4x. The y is going to become a minus 14y, and that's going to equal negative 4. Bottom equation is going to stay x plus 14y is equal to negative 1. Now we can add together. 4x and x is 5x. The y's add out, they are gone. Negative 4 plus negative 1 is negative 5. Divide by 5, I get x is equal to negative 1. Then again, just like all the other questions we've done with elimination, once you have one of the letters, you would take that and plug it back into either of the originals to find the other letter. So I'm going to go ahead and plug into number 2 again. You could plug into number 1. I have negative 1 plus 14y is equal to negative 1. I add 1. 14y is equal to 0. So this is going to be another one of those cases where one of our letters is 0, which again is perfectly acceptable. 0 is a number. It's allowed to be a solution. Your ordered pair then is negative 1, 0. So let's say at the beginning, maybe you decided you wanted to eliminate x instead of y. you have a 2x here and you have a 1x in equation number 2, you can actually turn the bottom equation into a negative 2x by multiplying it by negative 2. So if this were changed and instead of eliminating y, we were eliminating x, you'd keep number 1 the same and you multiply number 2 by negative 2. Again, that would be every term in there by negative 2. So it is possible to work this either way and you would still get the same correct solution. So go back through, rewatch this. You will have some practice on this lesson. There are other videos out there online if you're still struggling with how to do this. And as always, please reach out to me if you have any questions.